what this interview actually tests. It's not about training models from scratch or complex math. It's about whether you can take existing AI tools and build something real, securely, and reliably. 15 questions across 5 categories. Real answer, get the exact answer that make interviewers lean forward. Each question includes what they are really testing and what most freshers get wrong. Interviewer mindset insights. Understand what interviewers are actually looking for behind each question. Learn the red flags to avoid and pro tips to stand out. Category first, AI and machine learning foundations. Core concepts every AI engineer must know. Understanding the fundamentals of machine learning, deep learning, and generative AI forms the bedrock of AI engineering. This segment covers essential concepts that interviewers expect every freshers to know. Machine learning versus deep learning versus generative AI. Machine learning system that learn pattern from data to make predictions, uses algorithms to identify relationships and improve performance over time without explicit programming. Deep learning, subset of machine learning using neural networks with many layers, unstructured data like images, audio, and text, powers modern AI breakthrough. And what is generative AI? Generative AI is a subset of deep learning that creates new content, including text, images, and code. It uses neural networks to generate original outputs. The nested relationship, generative AI, deep learning, machine learning use nested circles to explain this relationship, usually in interviews. What is the large language model? Training and prediction, trained on massive text data to predict the next word in a sequence, learn statistical pattern, structure, and relationships from billions of text examples. Core architecture uses attention mechanism and transformer architecture, emergent capabilities including reasoning, summarization, translation, and code generation. Large language model emergent capabilities, reasoning and summarization. Large language models can perform complex logical reasoning, break down problems step by step, and condense lengthy document into concise summaries while retaining key information. Translation and code generation. These models translate between languages with contextual accuracy and generate functional code across multiple programming languages from natural language descriptions. Supervised versus unsupervised versus reinforcement learning. Supervised learning, trained on labeled data with input output pairs, the model learns from example where the correct answers is provided. Unsupervised learning finds pattern in unlabeled data without predefined outputs, discovers hidden structures and relationships in datasets. Reinforcement learning and RLHF. How it works? Learns by interacting with environment through trial and error. Agent receive rewards for good actions and penalties for bad ones, optimizing behavior over time. RLHF connection to LLMs. Reinforcement learning from human feedback fine tunes LLMs using human preferences as rewards, making outputs more helpful, harmless, and aligned with user intent. RAG versus RAG and LLM applications, building practical AI systems. This segment covers the core technologies that make modern AI applications work. Retrieval augmented generation, vector databases, prompt engineering, and when to choose fine tuning versus RAG. What is RAG and why it is important? Retrieval augmented generation. RAG adds a retrieval step before generation. It retrieves relevant documents, passes them as context, enabling grounded generation with accurate, up to date information. Solve critical LLM limitations, addresses outdated knowledge and hallucinations. Instead of relying solely on training data, RAG grounds responses in retrieved documents for reliable outputs. RAG pipeline explained. Document retrieval. RAG gets a retrieval step before generation. It retrieves relevant document from your knowledge base and passes them as a context to the LLM. Grounded generation. The LLM generates answer grounded in retrieved content, reducing hallucinations and providing accurate up-to-date responses. What is vector database and its role in RAG? Stores embedding. Vector databases numerical representation of text, meaning documents are converted into vector that capture semantic relationships, enabling AI system to understand content beyond keywords. Enables similarity search. User query converts to embedding. Similarity search find relevant chunks, retrieves context to for LLM. Example: Pinecone, ChromaDB, Viviat, Quadrant. Mention any one vector DB by name and detail. Vector database workflow, query processing, user query converts to embedding, then similarity search retrieves relevant chunk from stored vector. Popular vector databases, Pinecone, ChromaDB, Viawait, Quadrant, each optimized for storing and searching embeddings at scale. What is prompt engineering? Designing and refining prompts to get reliable, consistent output from LLMs, critical for cost efficiency, output quality, and security against prompt injection attacks. Key techniques to master: direct prompts without example, few short, including example in prompt, chain of thought, guide, step by step reasoning for complex tasks. Why prompt engineering matters: consists for consistency and reliability. Well-designed prompts ensure reliable, repeatable output across different queries. Techniques like chain of thought prompting guide the model through logical reasoning steps. Cost control and security. Efficient prompts reduce token uses and API costs. Proper prompt design also prevent prompt injection attacks that could compromise your AI system security. Fine tuning versus RAG, when to choose each. RAG for dynamic data. RAG retrieves external data at query time, best for dynamic, private, or frequently uploaded data that changes often. Best system combines both. Fine tune for tone, style, or domain specific language. Use RAG for current knowledge. The best system combine both approaches. Tools and frameworks. Essential technologies for AI engineers. Master the frameworks and libraries that power modern AI applications, from LangChain for orchestration to vector database for retrieval. These tools transform theoretical knowledge into production ready systems. What is LangChain and what problem does it solve? Framework for LLM powered apps. LangChain is powerful framework designed specifically for building applications powered by large language model. It simplifies complex AI development workflows. Key components and capabilities: handles chaining, memory retrieval, and tool use. Components include chains, agents, memory, and retrievers. Simplifies RAG and agent orchestration. LangChain components: chains, sequential LLM operations linked together. Agents, LLM that reason and select tools. Memory, maintain conversation, context, retrievers, fetch relevant documents. Always mention a real project you built with LangChain. Example: I built a document question and answer system using LangChain chains and ChromaDB retriever. What is AI agent versus simple LLM call? Simple LLM call: one prompt leads to one per response. The model receives input, generates output, and the interaction ends. No memory, no tools, no interaction. AI agents: LLM that can reason, choose tools, and act iteratively. Follows the loop: observe, think, act, observe. Example: calls weather API instead of guessing. The agent loop is iterative. Observe the environment, think about what action to take, act using available tools, then observe the result and repeat. Real world example: when asked about whether an agent calls a weather API instead of guessing, it observes the query, thinks about which tool to use, acts by calling the API, then observe the response. Python libraries every AI engineer should know. Core Python skills: master Python fundamentals, including classes, working with APIs, and async await patterns. These form the foundation for all AI engineering work. All SDKs. Essential libraries include OpenAI and Anthropic SDKs for accessing powerful language models. Know how to authenticate and make API calls. More essential libraries: LangChain for building LLM powered application, Llama Index for data ingestion and retrieval optimization, deployment and evaluation, Fast API and Docker for deployment, Ragas for RAG evaluation and manual evaluation techniques. System design and problem solving. Building real world AI systems, learn how to architect real world AI systems, debug RAG pipelines effectively, and tackle the practical challenges that separate theoretical knowledge from production ready solution. Build a document question and answer system. Step 1: ingestion. Collect documents from various sources, extract text, content, clean and pre process the data, then chunk documents into smaller segments for processing. Step 2: embedding. Convert text chunks into vector representation using embedding models. These numerical vectors capture semantic meaning for similarity search. Storage and retrieval. Store chunks in VectorDB with metadata. Query converts to embedding similarity. Search retrieves relevant chunks. Inject context into LLM for answer. Evaluation and monitoring. Log queries and responses. Monitor retrieval quality. Track user feedback. Continuously improve chunking and prompts based on result. How to debug a RAG system returning wrong answers. Identify the failure stage. The first step is debugging the determining where the problem originates. Ask yourself, is retrieval failing or generation failing? This question guides your entire debugging approach. Retrieval versus generation failures. If retrieval fails, adjust chunking strategy, try different embedding models, or implement hybrid search. If generation fails, improve your prompt or increase context window size. RAG debugging solution, retrieval fixes, adjust chunking strategy, try different embedding models, and implement hybrid search combining semantic and keyword search. Generation fixes, improve prompts instructions for clarity, increase context window size, and add explicit grounding requirements. What is hallucination? How to reduce it? A hallucination occurs when an LLM generates confident but factually false output. The model presents incorrect information as if it were true, which can mislead users. The insight cannot be solved. Avoid saying hallucination can be solved. It can only be mitigated through RAG grounding, explicit prompts, lower temperature, output validation, and verification steps. Reducing hallucination. Use RAG for grounding. Retrieve relevant documents to provide factual context. Ground LLM responses in verified source material rather than relying on parametric knowledge alone. Lower temperature settings, reduce temperature parameter for more deterministic outputs, add explicit prompt instructions, and implement output validation with verification steps for high stake use cases. Category 5th, behavioral and practical mindset. This segment covers how to demonstrate your value without work experience, showcase proof of capability through projects, and discuss future trends in AI engineering. Why hire you with no experience? Show proof of capability. Focus on demonstrating what you can do, not counting years. Show learning velocity, curiosity, and initiative through tangible work. Example, build a working RAG app. I built a RAG application using LangChain, ChromaDB. Here's my repo. Always have a project ready to demonstrate your skill. How to stand out, learning velocity, demonstrate curiosity and rapid learning ability. Show that you actively explore new AI tools, frameworks, and concepts beyond what's required. Project portfolio, always have a project ready to show when asked about experience. Say, here's my repo with working code, clear README, and documented learnings. Where is AI engineering going? Shift to agentic system. AI is moving from single step prompts to multi step agentic system that can reason, plan, and execute complex tasks autonomously. Key focus areas for the future, orchestration, evaluation, and observability will be critical. Learn framework like LangGraph, Ragas, and TrueLens to stay ahead. Frameworks to learn LangGraph framework for building stateful multi-actor application with LLMs enable complex agent orchestration and workflow management. Ragas and TrueLens. Ragas evaluation framework for RAG pipeline. TrueLens observability and evaluation for LLM apps, both critical for production AI systems. 30-day prep plan, week first and second. Refresher. Read LangChain docs thoroughly. Run your first ChromaDB query and understand vector storage basics. Build your first project. Build a RAG app using LangChain, ChromaDB, OpenAI, or Cloud. Push to GitHub with detailed README documenting your implementation. Week 3, add agent component to your project. Experiment with prompt engineering techniques. Add Raga's evaluation to measure performance. Week 4, practice all 15 questions aloud. Research target companies AI stack. Prepare 3 project and lesson learned. Freshers who get hired show projects. Clear reasoning. Start building this week. If this helped, like and subscribe. Thank you for watching. Subscribe for more AI content.